Okay, I chopped off some of the beginning of the stem of the problem, but it says in its fuel economy guide in 2008, the EPA gives data on 1152 vehicles, some outliers, so they got rid of those, and it says the combined city and highway gas mileage of the other vehicles is approximately normal, with a mean of 18.7 and a standard deviation of 4.3 miles per gallon. Okay, this is MPG. Alright, so now we can answer these three questions. Okay, in 2008, the four-cylinder has combined mileage of 25. What percent have worse gas mileage than the Malibu? So 35. You're going to want to look at it like this. Here's the mean, 18.7, standard deviation 4.3. The Malibu's up here at 25. What percent of all cars have worse gas mileage than the Malibu, than 25? Well, let's find the z-score. 25 minus 18.7 over 4.3. That's standardizing it, finding how many standard deviations above the mean are we. So that's going to be 25 minus 18.7 equals, divided by 4.3, 1.47, if I round it properly. So this z-score is 1.47, so I'm going to go to my, there we go, my z-score table, and I already forgot what it was, 1.47. And I'm going to look up 1.4, go all the way across here to 7, 0.9292. So this is going to be 92.92%. So 92.92% of all cars will have worse gas mileage than the Malibu. So that's not bad. Okay. All right, 36. Top 10%. How high must a 2008 vehicle's mileage be in order to fall in the top 10%? Okay. So top 10%. So check this out. We've got mu is 18.7. Sigma is 4.3. I'm trying to figure out what is this value so that this right here is 10%. This is going backwards now, aren't we? We're giving you the percent and saying find this value. I want to know what this value x is. Okay, let's go to the table here. And first we have to recognize that if this is 10% on this side, then this is 90% over here, right? Or 0.9. So I want this side on this over here to be 0.9. So I'm going to look in my table and try to find the value that's closest to 0.9. Okay. And wouldn't you know it, it's probably going to be the one that's cut off here. So here's 0.9032. And then I have to look on my table. I apologize. I'm going to look at my hard table here that I have on the side and see what that value is real quick. Because we want to pick the one that's the closest to 90%. And that one's 0.9015. And this is 0.8997. That one's actually the closest to 0.90. So we're going to use that. And that has a z-score of 1.28. Okay, does that make sense? You see that? 1.28 is the z-score that gives the closest to 90%. So if I go back to this problem, the z-score here is 1.28. Problem is I don't really care what the z-score is. I don't care about what's the miles per gallon for that. Well, I do know that the z-score is x minus mu over sigma. So if the z-score is 1.28, I'm trying to find x minus 18.7 all over 4.3. It says you don't need to solve equations or use algebra, right? So multiply by 4.3 equals x minus 18.7, and I'm going to add the 18.7, so I get x equals 1.28 times 4.3 plus 18.7, and we'll get 1.28 times 4.3 plus 18.7, and we get 24.2 miles per gallon. So that's the top. This right here is the 10%, I say the top 10% cutoff. Okay, does that make sense? All right. Now, how about this? The quartiles of the distribution for 37 are the values with cumulative proportions 25 and 75.25, or 25% and 75%. They span the middle half of the distribution. What are the quartiles of the distribution of gas mileage? In other words, for 37, we've got this distribution of gas, or the distribution of gas mileage. Mu is 18.7, sigma is 4.3, and we want to know what value is this and what value is this. I'll call this y, so that these are the quartiles, so that this is 25% and this over here is 25%, right? Because to be the quartiles, they're at the 25 below and 25 above. This would be Q1 and this would be Q3. Okay, we do that exactly the same way. We're going to look up on the table and calculate 25%. Okay, so I'm going to go on this one here on the negative z values, because I know it's going to be a negative z-score, right? Because it's to the left. So look up on here the closest you can to 25%, and it's going to be, I'm looking down here, it's going to be that guy right there. Okay, negative 0.67. Y'all see that? Z equals negative 0.67. Pause to make sure that you got that. See that that's the closest one. Here's 24.83, 25.46, 25.14. It's closest to 25%. So there's your z-score. So z equals negative 0.67. Gee, Wally, what do you think that's going to be? Since this is 25% and it's completely symmetric, good job, 0.67. And if you're not convinced of it, look on here and figure out which one's closest to 75%. And you can check that out yourself. Okay? 0.6 is closest to 75% is that guy right there. Okay? Alright, so let's finish this off. So we'll go ahead and do this. So you're going to have z equals x minus mu over sigma. So negative 0.67 x minus 18.7 over 4.3. And here you're going to have 0.67 equals x minus 18.7 over 4.3. And just like we did up here, we're going to solve them. X equals negative 0.67 times 4.3 plus 18.7. And here we have x equals 0.67 times 4.3 plus 18.7. And we'll calculate both of those and see what we get. Negative 0.67 times 4.3 plus 8.7. Boom, 15.8 mpg. This is Q1, the bottom quartile, and then we got 0.67 times 4.3 plus 18.7. 21.6. Always put units on. So this is Q3. All right, there you have it.